Hello and good day, everyone. Welcome back to my YouTube channel. This is Sir Marcy, and we are now on our second quarter, Module 2, Week 5. If you're new to my channel, please consider subscribing so that you'll be updated to my latest videos. Our objectives for today. After going through this module, you are expected to number 1, derive the product law of radicals, and number 2, simplify radical expressions using the product law of radicals. Let's try to evaluate the following. In our previous lesson, we evaluate radicals. Now let's try to evaluate this using prime factorization. Remember that the nth root of a raised to n is equal to a. So we're going to apply this in simplifying these radicals. So in number 1, if we have square root of 25, by prime factorization, that is simply 5 times 5. And then that is now equal to the square root of 5 raised to 2. Our index here is 2. Then applying the nth root of a raised to n is equal to a, our answer here is simply 5. Number 2, if we have square root of 9, that is 3 multiplied to 3. So that is square root of 3 raised to 2. So our index is 2 and the power is 2. So we can cancel them out. The answer is only 3. The same with number 3, we have square root of 121. By prime factorization, that's 11 times 11. So we have square root of 11 squared. Applying again, same index and same power, that's cancelled out, and the only answer here is 11. Okay, in our example number 4, we'll try to factor this by 9 times 3, and 9 is 3 times 3. So that is cube root of 3 raised to 3. So this is cancelled out. The answer is 3. Next is number 5. We have 4 times 4. This is 2 times 2. This is also 2 times 2. We have fourth root of 2 raised to 4. So cancel this out and the answer is 2. So I hope you remember how to simplify and evaluate radicals. Okay, this will be helpful in our next lesson, which is the product rule of for radicals. Our lesson for today is all about the product rule for radicals. In this video, we'll talk about simplifying radicals. Specifically, we're going to focus on product rule for radicals. So let's jump in and let's talk about product rule for radicals. If A is greater than or equal to 0 and B is greater than or equal to 0, meaning to say that A and B here are both non-negative, then the nth root of A times the nth root of B is equal to the nth root of A times B. We can also go backwards. If the nth root of AB, okay, so if we're going to do it backward, we have nth root of AB, that is equal to the nth root of A multiply to the nth root of B. Basically, when we talk about the product rule for radicals, it states that the nth root of the product of two non-negative number is equal to the product of their nth root. I just like to emphasize this one. A lot of students make this mistake. They see the product rule for radicals and they think they can apply this to addition. If you have the nth root of A plus B, that is not going to be equal to the nth root of A plus nth root of B. So don't do that. You might find a few special case where that one works, but don't think that it's gonna work all the time. Okay, let's try to simplify the following using the product law of radicals. So for number 1, we have square root of 12. So we list all the possible factors of 12. Let's say we have 12 times 1, we have 6 times 2, and we have 4 times 3. After we write all the factors, now is we're going to get the highest perfect square or HPS. So if we're going to examine, we have only 2. We have square root of 1 and square root of 4. So the highest perfect square we have is 4. So that means we're going to use square root of 4 multiply to 3. Then we apply the product law of radicals. So that is simply square root of 4 times square root of 3. Next is, if we're going to transform 4 in terms of exponent, that is square root of 2 raised to 2 times square root of 3. So we can cancel this out. Remember that the nth root of a raised to n is equal to a. So here, our answer is 2 square root of 3. Next, for letter B, if we're going to get the or if we're going to simplify square root of 4,000, let's say that is 100 times 40. That's 1,000 multiplied to 4. Then we have 400 multiplied to 10. So if we're going to get the highest perfect square, let's say we have 100, we have 4, and 400. So meaning to say we're going to use this factor. So that is square root of 400 multiplied to 10. Then applying the product law of radicals, that is square root of 400 times square root of 10. We know that square root of 400 is a perfect square, so we can write it as 20 squared multiplied to square root of 10. Applying this law again, we can cancel this out, and what is left is 20 square root of 10. Okay, so that's the answer for letter B. Square root of 4,000 is simply 20 square root of 10. Next, we have letter C. We have cube root of 108. So if we're going to factor 108, that is 27 times 4. So the highest perfect cube here we have is 27. So that is cube root of 27 times 4. Applying the product rule for radicals, we have cube root of 27 multiplied to cube root of 4. So if we will write 27 in terms of exponent, that's cube root of 3 raised to 3 multiplied to cube root of 4. So we can cancel this out, and the answer is simply 3 cube root of 4. Okay, and for our last example, we have fourth root of 32. So if we're going to factor 32, that is 16 times 2. Okay, so that is simply fourth root of 16 times fourth root of 2. Again, we can write 16 in terms of exponent, so that's fourth root of 2 raised to 4 times fourth root of 2. So we can cancel this out, and the answer is simply 2 fourth root of 2. Okay, if we're going to simplify fourth root of 32, the answer is 2 fourth root of 2.
That's all for now. Thank you for watching, and please don't forget to like and subscribe to my YouTube channel.